Do you remember this slide? This was your intro into discussing deployment, which, to jog your memory, is the process of taking application code and uploading it to a web server. Once an application is deployed, it can be used over the internet. In this whole section, you're gonna get much more familiar with modern practices of packaging applications into images and running them from containers. A small disclaimer at the start. I marked this section as an advanced topic, first of this kind in this course. If you're like me, you might get a little daunted by the notion of an advanced topic, but let me reassure you, I did my best here to present this knowledge in an approachable way. There are numerous diagrams and demos throughout this section to explain and visualize concepts as well as I could. Let's start by answering the question, why do we need to talk about containers? This is a key concepts course, and you'd be right, but talking to many of my students, I realize most of them, if not all, do come across Docker, Kubernetes, and containers in general at some point, and it's not an easy topic to understand. The truth is, in today's digital landscape, software deployment has taken a major leap forward with the widespread adoption of containers. Indeed, when we look at the modern large-scale applications, they're all running in containers. That's the new norm. As we progress through this section, I'll gradually feed you with bite-sized, digestible information about what these containers are, how they are constructed, managed, and more. For the time being though, let's begin by visualizing them in our diagram as unassuming boxes encircling applications. This is a simple but effective way to conceptualize that containers serve as protective casings or boxes for our applications. We're going to delve into the reasons behind the ubiquity of containers in the world of software development soon. But first, to aid in your understanding and to help you start forming some initial mental models, let's draw a parallel between containers and a relatable concept from the physical world. Let's consider an ice cube as a container. It holds water, the application and its dependencies, in a very specific frozen state. What's the function of an ice cube? To make a drink colder. This is the function of our application in this analogy. So if we've got just one drink to cool, we just open the freezer, take 2 cubes out and pop them into the glass. If you need to cool down a lot of drinks quickly, you don't make a giant ice cube. Instead, you use many regular-sized ice cubes. Similarly, when demand for your application increases, you don't build a larger application. Instead, you deploy more containers, each containing an isolated instance of that application. Ice cubes are compact and efficient in the way they hold and use water. Just as containers are lightweight, using shared system resources, instead of requiring a full operating system just like virtual machines do. More on them later, by the way. It's like using ice cubes to cool down your drink instead of putting your drink inside the fridge. Each ice cube cools down its drink independently of the other ice cubes. If one cube melts due to a hotter drink, it doesn't affect the other cubes. Similarly, containers are isolated. If one has a problem, it doesn't affect the others. If you need more ice cubes, you just fill the tray with water and freeze it. It's a quick and simple process, and each ice cube is identical to its predecessors. Similarly, creating another container is a swift and straightforward process, and every container is consistent with the ones before it. Regardless of where you freeze them, as long as you use the same water and freezing process, the ice cubes will be the same. Similarly, containers ensure the application will function the same way no matter where it's deployed.